All right, our configuration continues as we dive into Layer 2 Config Part 3. Now, just to bring us back up to speed, the flyby overview, we're configuring our Layer 2 network. We've got the base configuration put on each switch. We've got yes, we did configure the management VLAN interface. We even, in the last nugget, went through and added all the necessary VLANs to the correct switches, which now makes those VLANs active and makes that management interface active, actually, once we get an active port in it. Explain more on that later. We set up the Ether channel connections between the switches. So now we've got that port channel interface that we can configure, which groups all of those interfaces together. And now we move on to this. We are now at the point of configuring the links. So configure the links between the switches to forward traffic for all necessary VLANs. If a VLAN does not exist on a switch, the trunk should not forward traffic for it. So again, coming back to our diagram, switch 1, switch 2, switch 3, yes, Ether channel is configured, but as of right now, these guys are, well, we don't know their status. Yeah, they're probably access ports, or they could be in some kind of switch port mode dynamic or something like that. Either way, we want to hard code them as trunks and then filter the VLANs on those trunks to just be the specific ones that we need. So let's do it. Now let me get our notepad ready over here with our base config. So we're now, let's see, we've got Ether channel configured. So now we are into objective 3 or 4, trunking. All right, ready. So first thing we want to do is let's shoot up to switch 1. So where we left off last time was looking at the Ether channel, looking at the ports in there, making sure they're all in the port group and so on. But when we set up the Ether channel, let me do a show IP interface brief. You'll see we now have these virtual interfaces, port channel 1 and port channel 2. We refrain, we hold ourselves back from doing any config on the physical interface anymore. It's all now done on the port channel interface. So let's go into global config and do interface port channel. Let's go into 1. So this will be the port channel, the connection between switch 1 and switch 2. And I'm going to do switch port. Well, let's see what options we have. We have switch port trunk. This is one of the older iOS versions. And I don't like saying older. It's because different switches support different feature sets. Some of them will have you now this is new. Some of them will have you set the encapsulation, although with this one you can see the only option is .1q. Normally, if the switch does not support ISL, which is the alternative to .1q, ISL being the Cisco proprietary flavor that came out long ago and has been discontinued. Usually, if the switch doesn't support ISL, this whole command doesn't exist. Like, you'll type in switch port trunk encapsulation, it's like, sorry, invalid command. I don't know what command you're talking about, because the only option is .1q. But it looks like we have a train of the iOS that allows you to set it to only .1q, which kind of makes the command insignificant. Now I'm going to type in switch port mode trunk. Good. So now, look at that. Notice it caused the whole trunk to go down, or the interfaces to go down. They dropped out, then rejoined as the configuration was moved down to them. So let me do a show run interface port channel 1. Okay, so there's switch port trunk, and let's also look at interface fast Ethernet 01. Or wait a sec, no, 10. And you can see that the command has made its way onto the physical interfaces as well. Again, putting things under the port channel interface does that. Now, oh, did you see that? Look at that. Interface VLAN 1 just changed state to up. Well, what just happened behind the scenes? If I go back and do a show switch port, actually show interface, what command am I looking for? Show interface trunk. I love this output, because what this does is show me which interfaces. You can see port channel 1, that's its short little abbreviation for it. Port channel 1 is set to on, trunking is enabled, the native VLAN is set to 1, and it shows the VLANs allowed on the trunk is currently all of them. The ones that are currently forwarding, the ones that are not pruned out of there, are, well, all of the ones that exist for our environment. What happens when you bring up the trunk is initially it's initializing, it's adding behind the scenes, adding the trunks, adding the VLANs to the trunk. It takes some time to do that. That's why we didn't see VLAN 71 go active right away. But now look at this. This is when it said the VLAN 71 went active. This is what it meant. If I scroll back up here, look at this. If I scroll back here, before I enabled that trunk, our management VLAN was down. And the reason why is there were no ports that were in VLAN 71. So the switch said, well, if nothing's in VLAN 71, then there's no sense in keeping this up. It might as well just be turned off. It's down. It's not reachable. So once we went in and enabled our trunk, these guys came up, gave it some time. It added the VLAN. It was good, minute or so, 60 seconds before that happened. And then VLAN 71, I should say interface VLAN 71, our management interface on our switch now went active. If the other switches were trunking, I could now telnet to this. I could reach it, manage it, all that kind of thing. Let's also do a show interface port channel 1 switch port. And you're able to see the mode of this, and these verification commands are key especially when you're in the exam environment. You can see administrative mode is trunk, operational mode is trunk. Difference between those two is this is what you configured it for. This is what it's actually doing right now. This is config, this is real time. A lot of times on some switches they'll have the administrative mode be dynamic desirable, which is horrible because it's a huge security vulnerability. Somebody could accidentally or maliciously negotiate a trunk with your switch. So if you ever see administrative mode dynamic desirable, get that changed quick. Down here I can see all the VLANs that are active on that trunk. Now, before we leave this behind, hang on. Let me add those commands to our paper. There we go. I've just added in there. So we've got port channel 1 configured. I'm really curious if this command is necessary. Normally, if the switch supports that command, it won't actually let you type switch port mode trunk until you set the encapsulation. I was saying let's restrict the VLANs. That's where I was going. But hang on. Let's bring up the other port channel. Let's do interface port channel 2. This is the port channel going down to switch 3. So we'll go into that, let's just try switch port mode trunk. Hey, see, so it's not even required. Normally, if it supports this command, it would give you an error. So I'll keep it in there just for grins, but we'll also want to have port channel 2 configured as a trunk. So now we've got port channel 2 changed to up. Good. We're communicating. Now if we go back to our exercise, it said, so configure to forward traffic for all necessary VLANs. Done. We're now forwarding traffic for the VLANs on switch 1. We still have to do switch 2 and switch 3. But it says if a VLAN does not exist on a switch, the trunk should not forward traffic for it. So that's an additional command. Let's go back here to switch 1. And I'm curious if we can do an interface range for port channel. Hey, we can. 1 through 2. Hey, look at that. So I'm in interface range for both port channels. So I'm essentially configuring 4 physical interfaces at this point. I'm going to do switch port trunk. Now watch this syntax, and again, question mark is huge here. So I'm configuring the trunk, switch port trunk, allowed. So allowed, let's do a question mark. Okay, VLAN. So the VLANs that are allowed on this trunk are, well, let's see here. We've got the VLAN IDs that are allowed here. We go, okay, we can type our list. We can add one. We can say all VLANs. We remove. Now think with me. If you configure a trunk, what VLANs are allowed by default? All of them, right? Right, you got it. So if all VLANs are allowed, we need to trim that down. So going back to our list, we only need hey, I wonder if this will work. This list of VLANs. Okay. Some switches, and again, this is good. It's good that this stuff is happening because I've seen this before this is usually older switches. More modern switches don't do this, but it says, hey, bad VLAN allowed list, you've got to include the default VLANs. I would say 99% of the iOS versions I've seen don't make you do this, but check this out. Here's what it's meaning. You know when you do a show VLAN, and you see you've got now these are the ones that we added, right? Those VLANs exist on the switch, and we're going to trim down how many it's actually using on the trunk. That's what we're doing. But there's also VLAN 1, and then there's also these things, and everybody's like, "What's that?" You know, it's funny when I'm teaching somebody all about CCNA. That's the number one question. They're like, "What's that? What's VLAN 1002, 1003?" Those are just industry standard VLANs that have to be there. Meaning, when they wrote the VLAN standards, the powers that be out there said, "Well, you got to have a VLAN for FDDI and Token Ring," even though nobody uses it anymore. So you see it on all the switches. And what it's saying here is, if you're going to do this command, you also got to include the default one. So let's do it. First off, we got 1. We got to include on there because VLAN 1 is everywhere. And then I'll do 1002 through 1005. Add that to our allowed VLAN. There, now it took it. So now if I go back and do a show run, let's do interface port channel 1. Good. Now I can see my list of allowed VLANs. Notice I've trimmed it down. I've trimmed down to just the VLANs that the exercise said we needed on those switches. There's no sense in forwarding VLANs down to those switches that they don't need. Now, let me bring up something, and I will tell you, everybody does this once. It's like the Matrix, right? Everybody falls the first time they jump. So here's a mistake, and I want to avoid you doing it because it will cause a network outage. It will be one of those things where you have to go into a manager's office, get yelled at. Why did you do that? What were you thinking? All that kind of stuff. Maybe. But here's something that happens. Let's say down the road, down on switch 2, we have a need to add a server, right? I think that was VLAN 68. So we have to add that VLAN. So you go, okay, well, let me do that. You go on to that switch, you add VLAN 68, and it's funny because I know some of you that have a little experience know where I'm going with this. You add VLAN 68 to the switch. You're like, okay, good. I added VLAN 68. So now I need to add it in on the trunk. And so you go up here and right here, and here's the command. It's so easy to make this mistake. I've made this mistake more than once, so I'm not just saying, you know, you should. That's why I say it's bound to happen sometime. You're in a rush. You're on the syntax. You do switch port trunk allowed VLAN, and you go, okay, I need to add in 68. Doomed. Now I think, okay, yeah. So this iOS. Let's just see, make sure it did. This iOS bails us out, right? It's like, hey, bad VLAN allowed. You have to include the default VLANs. Normally, if you're on a more modern iOS or not on an EtherSwitch module, normally it will just take the command, and then your cell phone rings. Because what it will do is replace this whole list with just VLAN 68. Meaning the only allowed VLAN, it's an overwrite. The only allowed VLAN will be VLAN 68. So very dangerous, right? So you might be thinking, well, what do I do? Well, two things you could. You can either type in the whole VLAN list again and include VLAN 68 in that mix, or you use your context-sensitive help and you do allowed VLAN add. You see that? There's the keyword, right? Add VLAN 68. Now you're good. Now you can just go ahead and add in that one VLAN to the interface, and it's good to go. If I want to remove it, you can see that there's a remove keyword there as well. And I just did that. So I went ahead and removed VLAN 68 and updated our running config. So we've got the trunking config now. We just need to blast this onto switch 2 and switch 3. So let's hop over there. Switch 2, paste. There we go. Good, it's up. And switch 3, paste. Now let's, one thought just crossed my mind. If you want to save some time, the only reason it crossed my mind is because I saw this. DTP is the Dynamic Trunking Protocol. Also a good intention, bad idea by Cisco to negotiate trunks with the other side. Two issues with DTP. One is that's what leads to a lot of security vulnerabilities. And let me just talk about how this happens. Default mode for most switches is the port is in dynamic desirable. Now, in tech terms, what that means is the port is actively trying to negotiate a trunk with the other side using DTP. And if some malicious user comes into their cubicle out here, plugs in a managed switch from home that you know they pick up off eBay for 200 bucks or something like that, and plug it into their wall jack, DTP is like, oh, you support trunking, let's be a trunk. Wham, trunk immediately forms, sends all VLANs down to him, and now they can add whatever ports they want to their switch in whatever VLANs they want. They could hop on the server VLAN, they could go into the voice VLAN, whatever they want to do. So very, very scary, dangerous default on a lot of Cisco switches. So that's number one drawback, security vulnerabilities. Second thing, and by the way, let me step back and say I'm not bagging on Cisco. I totally appreciate their intention here, which was they wanted a plug-and-play network. That's what you can feel with this. They wanted you to be able to plug this switch to this switch, and man, you get a trunk, all the VLANs are going, you're like, man, Cisco's easy, this is the most amazing thing. And then someone down the road was like, yeah, that probably wasn't a good call. So the other thing is DTP adds about, oh, what was the number? I'm going to throw this out there. Don't quote me on it, but I want to say 2 seconds. 2 seconds to your time to bring up that trunk link. I know it's somewhere in that range, around 2 seconds. So what that means is, let's say you have, okay, let's go back to spanning tree. Let's say instead of doing Ether channel, one of these was a backup link. This one fails. It's going to take 2 more seconds to bring the link up if you're running DTP, meaning you're negotiating it, rather than disabling DTP. Now the tricky thing is even though we hard code the trunk ports, DTP still runs. It's still trying to negotiate and tell the other side, hey, I'm a trunk, hey, I'm a trunk, hey, I'm a trunk. So that's, again, not as secure, nor is it as fast to bring up the trunk. So the way that we nail this is we go into interface. Let's now I'm doing this. I don't know if this Ether switch module is going to do it or not. So let's do switch port trunk. Is that, hang on, now I'm doubting myself on the command. Switch port and switch port mode trunk. No, it's I believe it's switch, hang on, it's switch port trunk non-negotiate, I believe. I was off. It's just, I knew it was something simple. Switch port non-negotiate right here. That's the command to do it, and that is the one that disables DTP. That's what you want to do, but apparently I'm just looking to see if it gives that 2 second time, how much time it saves by doing that. But nonetheless, this is the command: switch port non-negotiate. This Ether switch module doesn't support that command, so that's okay. The lab didn't require that anyway. It was just a bonus value add for you. So now we've got. Let's get back to our objectives. We've got the switches configured for trunking just for the necessary VLANs. We've got those added in here on the VLANs. Now let's move on to the next objective, which is objective 5. Let's do VLAN port assignments. Switch 1. So come back here with me. You can see now we've got our trunks working. Now we need to assign the necessary ports to the VLANs based on the following tables. Ooh. Actually, do I want to? See, now that we're active here, let's go back. We should be able to telnet between all of our switches. Yep, see, all of our VLAN 71s have been brought up, our management interface, if our trunk is working correctly. Now, again, the lab hasn't asked us to do this or anything like that. I just get curious. So let's go to switch 1, and I'm not going to tell them. I'm just going to do ping. Let's do show IP interface brief include VLAN. So there's our VLAN 71. So let's see if we can ping 10.1.71.2. That's switch 2. I'm holding my breath. It's not working. Hang on. Okay. Well, that's good. Exactly what I expected to see. Because we wanted to see that. Let's do a show run interface port channel 1. Okay, this is going down there, right? We've got duplex full, and let's show IP interface brief. We're up, right? We've got our ports. They show up. Yes. Port channel 1. I'm having something in the back of my mind hit me right now of what this could be. Let's just do a show IP interface brief. No, it's up. Okay, so let's just 71.1. Not holding my breath this time. Okay, so we're still not successful. So here's my thought. Here's my thought. My thought. What is my thought? Let's do a show interface fast Ethernet 1/0. Let's look at one of the physical ports in there. Okay, this is my thought. Full duplex auto speed. And I knew when I set this. This was in the last nugget. I knew I was like, that's interesting that you can't set the speed on the port channel interface. You remember that? I went under the. Hang on, let me show you. Okay, this is weird. I've never. There's very rare where you have a full duplex auto speed, and if you do, usually it takes the port down. That's why I'm really curious why the ports aren't down. Usually you have to, once you hard code one, you got to hard code the other. So what I was showing you in the last nugget is I went into the port channel interface, port channel 1, and I did speed, and that's not supported under here. You got spanning tree, but not speed. So that's something that we have to set under the physical interfaces themselves. So let's try this between switch 1 and switch 2. I'm going to go into interface range fast Ethernet. We'll do 1/0 through 1, right? That was the interface, 1/0. And let's do speed 100. Physical interfaces will take it. Okay, okay. Tore it down. Everything went down. Now it's coming back up. Okay, I'm going to go over to switch 1. I'm just following a rabbit trail here. Kind of hop along with me. Let's do interface range FA 1/0 through 1. Let's do speed 100 there as well, because once you change one side, it's going to be down until the other side gets changed. Okay, so we're up. I'm still not seeing the port channel come back up, though. Oh, wait, port channel did come up. I'm not seeing the... What am I not seeing? The management... Oh, I guess the management interface, VLAN 71, never did go down. So... Okay, so there it is. So the management interface went up here. It stayed active on switch 1 because it still had the link over to switch 3, keeping it active. So let's try it. So let's see if that resolved it. Ping 10.1.71.2. That's switch 2. Okay, that's not working either. Ponder with me. What is going on? Let's do a show run interface FA 0 or 1/0. Switch 1. See, this is where it gets kind of fun. Some people are like, "Oh, it's not working." I'm like, "Hey, this is cool." Unless you realize it's a GNS3 bug or something like that. But I'm looking here. We've got duplex full speed 100 under the fast Ethernet port. That's good. And that is the right interfaces, right? That's let me hang on, let me bring up GNS3. 0 and 1, yes, it's going down to switch 2. Good. Just want to make sure I set the right ones there. Okay, let's see. What else could I do? Ether channels. Maybe ether channel not working. Ether channel might not be working. Let's try this. Now this is going to destroy our ether channel, but it'll at least tell us if it's an issue related to ether channel or not. So let's do interface range FA 1/0 through 1. Let's do no channel group 1. Enter. We'll yank them both out of the channel group. Port channel 1 went down, and that's fine. Let's also go down here because we've got to do it to both these guys too. Actually, I'm already in that interface, so no channel group 1. Tear those guys out of the channel group. Okay, so port channel has gone down. So now spanning tree is going to come in and block one of those ports. Let's do a show spanning tree. Show spanning tree brief. There we go. Show spanning tree brief. Okay, there we go. Look at that. So we've got VLAN 1, and it's going to show for every single VLAN, VLAN 64, 66, so on. But we can just look at VLAN 1. Actually, let's look at the VLAN that brief for... it doesn't let you just focus in on that VLAN. Show VLAN, show spanning tree. Hang on. Show spanning tree. VLAN, what was it? 71 is our... bridge. I'm looking at the bridge group. All right, so let's just do show spanning tree brief. Okay, so we can see, and it's going to be the same way for all the VLANs. We've got VLAN 1, Fast Ethernet 1/0 is forwarding, that's our forwarding port. The next one, 1/1, has been blocked. So Spanning Tree is doing its job. Just bonus information, if you will, but I wanted to make sure that the port channel has gone down to see if the Ether channel is causing something with this. So now, let's go back up here. Port channel 1 is down, but we should see that the interfaces are still up. It is. So let's do that ping now. No. It's not supposed to do this. Okay, what else do we have here? Let's look at the configs. Let's do a show run interface FA's 1/show. See, it's fun because this is being recorded, and I know a lot of times people will see things and they're like, it's right there, but I'm stuck, I can't hear you, and so now I just have to follow my own intuition. Let's do a show run interface F 1/0. I'm just comparing. Okay, so we've got VLAN 1. Let's do a show. The big thing I'm looking for, I just want to see VLAN 71 added to both sides, and it is. That's our management interface that I'm active on. Let's just do, I just want to see a show interface VLAN 71 as well. Make sure it's up. It is up on both sides. Let's do a show interface VLAN 71 on switch 2. It's up on both sides. It's good. Good. Okay, so I've got 15 packets output, nothing input, nothing being received. Why? Let's do a, I'm just curious, let's do a show ARP and see if we don't have even the MAC address of relating to switch 2, 71.2. It's always the simple things. Let's see. So we've got VLAN 71. It's active on both sides. Maybe, no, I thought maybe the VLAN wouldn't be created, but if the VLAN weren't there, the management interface would be down. Let's do a show VLAN switch. Got the management VLAN, that's on switch 1, and let's do show VLAN switch. Management VLAN, they are added, and that's a common error. Is if you forget to add the VLAN, it will go down. There's no ports in it, but that's because Fast Ethernet 1/0 is a trunk. Now we haven't tested 3 yet. I'm just curious, maybe 3 works. Let's go back up here and do a ping to 71.3. Negative, Captain. So we are not getting any kind of ping traffic whatsoever. Wow, what on earth? It's funny because the config is so simple so far. Something so basic, unless I'm just doing something silly like typing the wrong IP address or something. So we've got our port channels are right there. It's good. We've got VLAN, allowed VLAN. That's good. I didn't add the speed on the other ones, but that's fine because we still don't know if that's an issue. I've torn down the Ether channel. Let's see. VLAN 1, no IP address, shut down. Yeah, that looks so good. So 10.1.71.1. Let's do a show run on switch 2. Okay, there's our port channel, but we're not using that. We've got VLAN 71 allowed right there. Switch port mode trunk. And VLAN 71, 10.1.71.2. 2. Anything else? Anything else that would cause this? Ping. So let's see. Let's do this. Let me go back to some core troubleshooting. Let's do a show CDP neighbors. Okay, so we're getting some communication there. We've got switch 2 and switch 3 that are both being seen on both the right ports. So that tells us physically we're good. So why? Let's do a show CDP neighbors detail. Look at that! It's even seeing the IP address of the other side. So why are the pings? The more this goes, the more I'm like, this has got to be a GNS 3 something or another. because if you're seeing them, the VLAN's forwarding across, you're even seeing the IP address via CDP. Something's funny here. Let's try this. I'm going to try saving the config on all these guys. And I know this sounds funny, but I'm going to reboot them. Let's okay, last time I tried this was many versions ago, but last time I tried to reload, bad things happened. Let's see if it's still... Well, let me pause the video while bad things happen. Hello, I'm back. The beauty of video. For you, a single second passed. For me, an entire day passed. I spent just let me backtrack of where I've been over the last day, and I didn't spend all day on it, but it did take some time. I sat here pulling out my hair. The routers wouldn't reload, and once I did stop them and restart them in GNS3, they all rebooted with no configuration. And I thought, okay, that's not good. And so I went on a little scavenge and found out through just a chain of Google searches that you shouldn't use the 3745 router in GNS3. There's known issues with it. And everybody, all the posting that I said, it said get away from the 3745. And by the way, that's the router model that I was using for everything. It said use the 3725 instead. So again, the long chain of events, I shut everything down. What I did was I got an iOS version for the 3725, and I actually want to show you what I did, because it's going to save you all the GNS3 pain, but I know sometimes you're going to run into challenges using GNS3, and I just want to show you what I did was I went into, this is my GNS3 topology. This is when you save in GNS3, this is what it generates. I made a backup copy of my topology, and I can show that to you. You can see that this was before I made any changes, and it's very clear text. It's like an XML style, and you can see that we've got, 3745 is the image. This is where it shows what image I was using and so on, and the idle PC value, and then it shows all of the different routers, what model they are, where they are, the coordinates on the, so that GNS3 knows where to put them on the diagram. So you scroll down, you can see everything about it. What I did was I went through and made modified the topology, downloaded a new a copy of the 3725 iOS, 12.4 release 18, and then just went through. I just did a find replace and changed everything from 3745 to 3725, because that way I don't have to delete my whole topology and recreate it. Save that guy. Once I booted it back up, I'm telling you, and I wish, sure, I wish you could have a 2-hour recording and showing everything I did, but good grief, who would want to watch that? But after I powered everything back on, everything works. So let me bring it back up. I did have to paste in my configurations again because they were lost. The 3745 does not save too well, apparently. So I pasted the configs back in, which was easy because we had them all recorded in our little answer key that we generated as we went. And once I did, now you can see same config I just left off at before. I've got the two VLAN interfaces. VLAN 71 is the management interface, and when I ping 10.1.71.2, you can see success, and then there's .3 success. Everything's working fine. I can shoot over to switch 3. There's my VLAN 71 interface, so I'll do a ping 10.1.71.1, that's switch 1, and .2, which is switch 2. So we've got full communication across our trunks on VLAN 71. That was my whole goal in improving that. Now, normally I would go back and say, well, let's just re-record everything I did, but I wanted to leave all the troubleshooting in there. I actually listened back through, trying to figure it out, and I had that weird feeling it was a GNS3 thing. But I want to leave all that in there because just the flow that I went through in troubleshooting that I think is valuable, just so you can see, okay, we went to try and ping, check the trunks, check the VLANs, did show to CDP, check the neighbors, all of those things, putting them together. I think that adds some value to it. So let's see, where are we? Let me Like I said, it's a new day. I stopped. I went on to other projects, and now it's a new day. So I got to reorient myself, make sure where we are. So we left off. That was configuring the links between the switches to forward traffic for all necessary VLANs, the trunk port. So the trunk port is now configured. Now we can go down and assign the necessary ports to the VLANs based on the table. So what we've got is we've got switch 1. Fast Ethernet 10, 11, 12, 13 are all trunks, and that's already done. Matter of fact, everything with trunk here is already done simply because we created the Ether channel and then just a moment ago went through and enabled everything for trunking on that port channel interface. So that's good. So right here I can see I've got Fast Ethernet on switch 1, Fast Ethernet 1/4 through 13. Is going to be on VLAN 68. And you remember that VLAN is the server VLAN. So we're assuming a bunch of servers are going to be connected to switch 1. So let's just go do that now. Bring my config window back up. Just want to make sure everything is good. So we've got our server VLAN there. Let's go and notice when you're doing a show VLAN, all of the ports essentially 0 through 3 are missing from the output. Trunks just don't show up in the show VLAN. That's where you use that show interface trunk. And I can see, oh, I've got my 2 port channels. I go, oh, well, what's in the port channel? That's the show ether channel summary. So I can see, oh, there's all my physical interfaces in the port channel. So that's how you can verify what's where. So now let's go to do VLAN 68. It said, hang on, let me scroll back down, ports 4 through 13. So let's get into global config mode. Interface range fast Ethernet 1/4 through 13. Got to get the spacing right. Now I'm going to do something here. I'm going to do something which the lab didn't ask this, but actually it probably would be good for me to edit the lab and add this in. I kind of think of things as I go because it would be a good thing. So I'm gonna just write myself a note. Good old notepad. Add access ports to lab. The reason why I'm saying this is because the default mode of every port is that dynamic desirable. And anytime, it's almost second nature to me. Before I even assign a VLAN to a port, I'll type in switch port mode access, which hard codes it as an access port. And what that means is it's only on one VLAN. It can only be on one VLAN at that point. There's not going to be the nervousness of somebody connecting another switch and it automatically forming a trunk or anything like that. So hard coding an access port says this will be assigned to a single VLAN, and that VLAN happens to be, so I'll do switch port access VLAN 68. VLAN 68. Let's do a show VLAN switch. And now you can see the vast majority of all the ports on this switch have now moved over to VLAN 68. They're completely separate now from everything else on the switch because we don't have any inner VLAN routing. So VLAN 68, all these ports cannot reach anything but what's in VLAN 68. So good. Let's get the rest of switch 1 and then we'll throw it in our file. So Fast Ethernet 1/14 will be VLAN 70. That was going to be the private lab. Okay, remember in the MDF, the company said that we could have our own private lab as long as it's completely separate from the corporate network. So that's going to be our port. So we can connect that to a lab switch if we want to, or a PC. So I'm going to go exit out of this VLAN range mode. Let's go interface Fast Ethernet 1/15. No, 14, right? Yes, 14. Switch port mode access. Switch port access VLAN 70, which is our private lab. Good. Okay, so now I've got that moved over there. Do a show VLAN, just verifying we've now got that port moved into the private lab space. Then the last one, oh, and this is a good one. Last one, it says, I got to shrink this down. Last one right here, it says will be a routed port. Now again, this one goes beyond the CCNA. We're in multi-layer switch world. This port, and let me bring up the interfaces here, show labels. Fast Ethernet 1/15, which is this guy, is going to be connected to the router, and that's going to be configured as a routed port, meaning I'm turning off the switching capabilities. Now let me show you. There's a couple ways you could go about this. Check this out. I'm going to go back to the diagram. One way, clear that off. One way is to go in. I could create, for instance, my own little VLAN. Let's just say I create VLAN 100, just for this example. VLAN 100. And I say, okay, Fast Ethernet 1/15 is now in VLAN 100. It would be in VLAN 100. And then I would create a routed interface. I would type in interface VLAN 100 and give it an IP address that would be able to communicate to that router. Now, I think if I don't remember, but if we went back to the diagram, I thought it was, wait a second, it was 10.1.254. Excuse me, .0/30. So that gives us usable IP address of 1 and 2 that we can use. So I would say, okay, this side is 10.1.254.1, and then this one would be 10.1.254.2, /30. The .252 subnet mask. So they would kind of have their own little subnet right there, but that kind of, you usually, and let me give you a generality, you'll usually create a VLAN interface when you got a bunch of stuff in VLAN 100. Like there would be other ports in VLAN 100 in this VLAN between the router and the switch, but in this case, there's not. This is kind of like a little point-to-point link. I've got the switch over here, one point, and then I've got the router over here, another point. I've kind of got this little point-to-point link. So instead of creating a VLAN interface, here's what you can do. I can go in to this port and type in the command no switch port, which says, no, this no longer belongs to the switching engine. This is now a routed port. And then I can assign the IP address directly to that interface, 10.1.254.1/30. Now, what that does is nothing else can be in that subnet. This is now it's a true point-to-point link, if you will, between the switch and the router, but that's okay. I don't want anything else to be in that subnet. It's just a kind of a direct link. So this guy will have all the VLAN, all of the VLAN interfaces here. VLAN 68, VLAN 70. I'm just throwing them out there. 64, 66, all the VLANs that we have created. It'll have all the IP addresses. It'll be the router, the layer 3 switch that allows this VLAN to get off, and these PCs, they'll come in here. I mean, let's do a little traffic flow. Let's say this guy wanted to surf the net. He would come up, hit his default gateway, which would be assigned to, we'll say, well, he's not a server, but we'll just say this IP address on VLAN 68. If he were in VLAN 68, it would hit that default gateway. The router in the switch would then look at its routing table going, where are you going? And he would have gone somewhere. Let's say he's going to Google, or he's pinging 4.2.2.2, the DNS server out here that is 4.2.2.2. Well, it's going to look at the routing table and go, oh, well, I don't have 4.2.2.2, but I do have a default route. A default route that says send everything to the router. Now, we're not going to implement this in this nugget. That's going to be when we get to the routing function, but I want to give you a sneak peek of where we're going. What we're doing in this nugget is setting up the routed interface between these two guys. So watch. I'm pondering to myself, is there more to say? There's always more to say, but let's do it, because we've got 14 configured. So now let's go into interface Fast Ethernet 1/15. Actually, I haven't tested this on the EtherSwitch module. I think it'll work. Oh, good. It paused. I'm like, oh no, it's not going to work. Okay, it is. So we've got no switch port, and you can see just like that. It says, okay, the line is now changed to up. It sees an active link between it and the router, and let's do IP address. I got to go back to my spreadsheet. There we go. Bring that into the picture. So right here, this is the point-to-point exit subnet that I configured in our planning phase. And you can see VLAN not applicable. It doesn't belong to a VLAN. It's a routed interface. So I just said the 10.1.254.0 subnet, .252 gateway. So usually I would have had on the network diagram or somewhere, in the list. Actually, do I have it in my port list? No, I stopped, and these are even gigabit ports. I've got fast. It's an idea. It's just not. This would be fast Ethernet and all that. But anyway, it would be down here. I would have gone in and said, okay, VLAN trunk or IP address. I would say this side is 10.1.254.1/30. And I would put nodes exit to Nugget Labs branch 1 RT 1. That's the router, I believe. RT1, right. So that'll be our internet connection. So that's where I'll come back here and do IP address 10.1.254.1, 255.255.255.252. Good. Huh? Pretty cool. So we just assigned an IP address now to a port that was a switch port, but no more. It's now a routed port. Do a show IP interface brief, and look at this. Now we've got this exit point, this fast Ethernet 0 slash or fast Ethernet 1/15 that now can be used to get to the internet. Now, I'm not putting the rest of the pieces in place, but eventually I would go in and I'd do IP route, all zeros. I'd say, okay, my default route out on my multi-layer switch is going to be 10.1.254.2. That's going, and the .2 side would of course be assigned to router 1, who would do NAT and get me out to the internet and all of that. So, that's cool. So that's configuring a layer 3 switch. And how that works, and I could talk on that so much more, but we've got to get back to our objectives. So we've got switch 1 done. I want to put all of the commands we typed before I go to switch 2 and 3, all the commands we typed into the notepad file. All right, I got it. So here's the boiled down version. You know what? If you ever are like, so what did we talk about in that lab? And you want it without Jeremy's thoughts, commentaries all around it, this is it. I mean, this is like hardcore. This is how we accomplished that objective on switch 1. It's just, as I was doing this, I was thinking, I just had a conversation with a guy who also teaches online, named Simon. He actually teaches for another online company, the dark side of the force. But anyway, I said, so we were just hanging out, and I said, so tell me, if you were to say, like if you were trying to tell somebody how to teach online, what is like the top 3 things you would tell them? And because I'm thinking, he's very well spoken, he's a great guy, and he said, number 1, script everything, and I said, seriously, like script it? He's like, yeah. He's like, when you're teaching online, be an enthusiastic reader. That's it. He's like, just create your script, read the script, and I'm like, oh, I'm looking at him like he's saying vulgarities. I'm like, how could you do that? How do you talk to a script? And he's like, that's all I do. And he's like, I'm in, I'm out, I give them what they need, and that's it. I'm like, oh, what a joyless teaching. So anyway, he's the funny thing is, he's very, very good. He's just, anyway, I could go on about this guy. He's a great, funny guy. So anyway, so switch 2, switch 3. Let's now move into those worlds. Let's see. So I'm going to go to switch 2. And I'm just bringing my chart back into it. We've got the trunks configured. This one should be easy. But need a little explanation. Look at this. These fast Ethernet 1/2 through 14 on both switch 2 and switch 3 are going to be our client ports. Remember, this is where our clients are connecting. But remember, they're not pictured here, but our clients actually aren't plugged in just like they're shown. They're going to an IP phone. Remember, they're doing voice over IP. And then that ends up connecting to the PC behind the scenes. So when I said client port, I actually put on VLAN 64 and 66. 64 being the voice VLAN, 66 being the data VLAN. Let me show you how that's done. So I'm going to go over to switch 2. You know what? This feature, can you see this? I don't know if you can. This feature in Windows, arrow, I don't know if that recorded or not, where it flips between them all. Very cool anyway, but I never use that. It frustrates me. So, what am I doing? Right now I'm like, if only I had a script. All right, so let's go in here. Switch 2. Interface, fast Ethernet 1/2 through 14. No. Oh, interface range. So I'm in the interface range config mode now. Let's do switch port mode access. Put them into access ports. Now here's how we play this dual VLAN thing. We do switch port access VLAN, and that was going to be, I just want to double verify, 66 I believe. That's the data. So the access VLAN is going to be the one that the computer resides on. That doesn't change. So I'll say VLAN 66. But now Cisco's added another command that you can type in, switch port voice VLAN 64. Ah, now that's a new one. Now, I would say, I'm not going to say it's brand new. This has been around for a while. But before they had this, you could do this. Before they had this command didn't always exist. You could do this, but what you would have to do is you would have to configure this port. Let me grab the right pen here. Configure this port as a trunk. And I would have to limit, I would say allowed VLANs would be 64 and 66. 66, which is our data VLAN, would be configured as what's called the native VLAN, or the untagged VLAN on there. And so what it would do, it would accomplish the same thing, but you have this trunk thing. It's just a lot more complex to do. But essentially, it would send the packets to the phone on VLAN 64, that's our voice VLAN, as tagged packets. It would keep that VLAN tag on there because Cisco phones can understand VLAN tags and they can speak with VLAN tags. The computer, not so much. They don't have the ability to understand tags, at least normal computers with normal people operating them. So you would send that untagged on VLAN 66, and that would be considered the native or untagged VLAN going out that port. That was the old school way of doing it. Nowadays, Cisco has made it very easy for us. The last one is going to be kind of neat. This is how we configure our wireless access point. Where's my lab? There we go. The last one, Fast Ethernet 1/15, is going to be our wireless access point connection, and that's going to have VLAN 66 and 69. 66 will be our client data. So if somebody joins the wireless network with the correct credentials, that's the key, then we'll put them on VLAN 66 right here. If they don't have the correct credentials, meaning they would choose a different SSID called public or something that doesn't require any credentials, then we'll put them on VLAN 69. Now, it's the client who chooses. They've got their laptop, right? They see the wireless networks. They would say, well, I want to join the private network, or I want to join the public network. If they join the private, it asks them for a password. That's the way we have it set up. If they join the public, there is no password. So that's going to be dictating which VLAN they end up on. And later on, we're going to set up the access restrictions. So VLAN 69 can't touch a thing except the internet. So let's get into our config. And now this will be what you would expect. This is kind of the old way of configuring the voice ports. So this one, I would go in and do switchboard mode trunk. And now I'm running I was just wondering if it would support the non-negotiate on this 3725, but no luck. So switchport mode trunk, that's fine. And then we would go in and do switchport trunk allowed VLAN, and this is where I would do the VLAN, what was it, 66 and 69. Same error as before. So 1 comma, and then we had the 1002 through 1005. There we go. So again, really, we're just allowing VLAN 66 and 69 since these don't even really exist, and this is just the default native VLAN out that port. Now, when we configure the wireless access point in the future, you know, we'll have in port FA 1/15, we'll have our little wireless widget plugged in. We've got to set it up to where we note on the access point. I'd love to add this into this series. We say SSID, we'll say public is actually associated with VLAN 69. SSID, we'll say private, and I know I documented what these would be associated with VLAN 66. I mean the names of the wireless network. So based on what you join, that will send the tags, that's the big thing, tagged packets out into the trunk port. It puts it on the right VLAN, sends it up to our multi-layer switch, which does all the access control. That's later. I'm just showing you where we're going with this. So that's switch 2. Let me add all that to our documents. All right, that's done, and just show you my config. It's funny, I noticed, maybe you saw this, but I actually before typed in interface range Fast Ethernet 1/15. You don't have to use the range there. I think I hit the up arrow, but I fixed it in the config. And the nice thing is, this now makes switch 3 very easy because I can go in, copy that to the clipboard. Because now let me just double check. Yeah, switch 3 is exactly mirrored configuration of switch 2. So let's drop over to switch 3. And now that I've got that in here, I lost my clipboard. Copy, paste. Voila. Oh, see, I'm glad that happened. I got to fix my config file. 1, comma, and then add these guys in there. Good. So that will now complete that objective for us. Let's just go back to the diagram. Okay, good. So we've got all the ports in the right VLANs, and wow, a lot of stuff packed into one nugget. Let me conclude there. In wrapping this up, I would say we accomplished some pretty major objectives. 1, we've got all of the trunks configured between them. 2, we ended up figuring out GNS3 doesn't work well with the 3745 router. You want to use 3725s everywhere, which was good fun. That's probably where I spent most of my time in working through this. So we've got that fixed for now and for the future. We've got the trunks configured. We've got all of the trunks throttled, and we got to test the trunks. I know it wasn't part of the lab, but I wanted to test the trunks, and I'm glad I did, because once we added all the other stuff to it, if we tested then, I would have gone, well, what's going on? There's a lot bigger picture to test. So that helped us figure out the GNS3 issue. So we tested that. We've got management interfaces pinging all throughout the network. We've got the ports assigned to the right VLANs. We've got voice VLANs configured. We've got the wireless access points ports configured, so they're now ready to connect to the wireless access point. Oh, I just thought of something. One of the things that I know everybody's like, no, don't do it, Jeremy. Just conclude. Say thank you for viewing. That's it. That's all. There's no more. No, there is. I didn't even think of this. I got to add this to the lab. That's one more thing. Add access ports and add management for the wireless access points to the lab. And now, by the time you see this, these are all going to be in the lab, so you're going to be going, well, they're already there. Well, of course, but they're not there for me. Remember I had the wireless access point plugged in here, and I said, okay, we've got VLAN 66 for the private VLAN and VLAN 69 for the public. Well, this wireless access point itself will be assigned an IP address. Matter of fact, if I remember my spreadsheet, and I know I do, I'll come down here to my VLANs and subnets, and I had allocated right there on the management VLAN 71, we would have the wireless access points assigned an IP address so we could manage them, meaning I can configure them, I can monitor them remotely. But here's the problem. I didn't add the management VLAN to the trunks, VLAN 71, so it doesn't matter when I configure this access point, if I configure the management IP address for VLAN 71, and I'm totally going to get a wireless access point to show you all this, but it won't be able to talk because the trunk is only allowing, remember we throttled it back, allowed VLAN 6669, we didn't add in VLAN 71, so I'm just, for now, I mean, well, okay. I can't not do it. So I'm going to go into here and let's do switch port allowed VLAN. I've got the command right there, so let's add 71 to the mix on both switch 2 and switch 3. That was for our wireless access point port. So now we'll have management capabilities, and so that's something I'm going to have to adjust the lab to include management for those wireless access points. I'm glad I reviewed. I'm glad I thought of that. So with that, okay, I'm done. I hope this has been informative for you, and I'd like to thank you for viewing.